Hello, in the previous video we took a look at the procedure to set up a circuit trace application. So now we will run that application. To do so, we'll go over to the system menu, go to open project, select the app, and we'll take a quick look before we get involved with this at the controller. There's a USB JTAG controller attached. It has two channels, and we have assigned JTAG chain A to channel A, chain B to channel B, and these can be changed around depending on what you want to do. There are some settings, for example, TCK rate, which is now set at 1 megahertz. It can be set up to 30 megahertz. So those are some of the options. You can come in, you can statically drive and set these pins if you want to. There's no need to do it right now, but that's one of the possibilities. So looking at the JTAG Ops menu, we see there's the possibility to create a tap infrastructure test. So we can test the JTAG chain if we wanted the tap on it. We can create the test. And we can run that test, and when we do so, we'll see that the various parts of the test, instruction capture, instruction register length, bypass register test, ID codes, all passed. Boundary register length test passed. And that test can be customized over in the solutions panel. You can come in and expand some of these items and check or uncheck them depending on what you want to do in this tap infrastructure test. So okay, so we know that the tap is working. We can then wiggle some pins, and to do that we can go into the circuit area. A good way to do it: select a device, select a pin, and we can use these controls right here on this toolbar. We're driving a pin high, driving a pin low. And notice when we do so, all of the other pins have an arrow next to them, and that's simply the scanned value. All of the pins are tested when one pin is driven, and the values on those pins are captured at the TDO scan point. So if we want, we can look at the I/O type of a pin. It's an input-output. It could be just an input or an output, for example, an O or a B for a buffer. So if we wanted to pick a pin to wiggle or do some other operation, we might want to know what kind of I/O pin it is. If we want to go back and look at the values, we can do that. And let's say we want to trace the values on a pin, so we can come over here, and for this selected pin we can trace the connections on that pin. And so what we're finding is that the pin is connected to U3 pin 8, which we have selected, is connected to U3 pin 24 as well as U3 pin 20. That's what Circuit Trace found in scanning the board and broadcasting signals from this pin. So we want to know, let's say we want to use this as a future test, as a reference test. What we can do is we can check, well, is that really a good connection? So we can select the pin and come over here and wiggle that pin and see, oh, all three pins go high at the same time. All three pins go low at the same time. So that looks like a legitimate connection. So we can come over and where it says connect, we can say tests OK. We do that to both of them. And notice now we have green arrows. So if we were to go back and test U3 pin 8, it would come up with green arrows. So in this way you can set up reference tests for one or more pins, or for all of the pins on the board. So let's say we do want to test all of the pins on the board. We simply come over here, and Circuit Trace will scan through all of the pins and report their connection status. Now in this simple app we don't have a net list, so we can't really browse back and forth like we would be able to do with a net list. So we basically browse back and forth and confirm the connections. So what we do in this case is, again, we check a pin, we wiggle it and see what's connected, and we would have to go through the list and determine what's legitimately working and what's not. And that would be the procedure to scan all of the pins. But once you've done that, you then have a reference test. And if you want, you can come in with another board, test all of the pins and see if it matches, say, the golden board. If you had a net list, you would be able to verify the connections actually on the net list rather than broadcasting from pin to pin. Another thing that we can do is we can monitor the pins on the board, and any of the active pins that are switching because of background clocks, in the application or mission mode of the board will show up here. If we wanted, we could select the pin and just observe it and watch it. You might have some particular signal on the board in application mode that you want to watch, and that can be done here. Okay, we're going to stop that. And I should mention that you can set constraints so that while you're doing these various operations, you can hold pins, drive them high or low statically, you can turn them off, you can do a number of settings. In a similar manner, you can put this in nets mode, and you can select particular nets if you want to do that. See, we'll go to nets mode. You can select particular nets and assign them as power or ground. So, what else can we do here? We could, if we had Circuit Trace Pro, we can run SVF files, for example, Flash programs. We can run those. And in addition, we can do something else. We can run script programs. So if we have a script program, so we can either type a script program in or just copy and paste it in. And then we have a number of options to, for example, run it and do some other things. But script programming is going to be covered in another video, the next video. So thank you for watching.